Welcome to the first online lecture of electronic circuit design. Today I am going to discuss the BJT current mirror, and the topics that I am going to discuss are covered in these pages of the book. So, as we discussed in class already, that the BJT current mirror comprises of two transistors Q1 and Q2 that are connected back to back. The base to emitter voltage is same for both the transistors, which is VBE. So the collector current flowing through transistor Q1 is IC1 and given by this relation. The collector current flowing through Q2 is IC2 and given by this relation. So ratio of IC2 to IC1, the ratio of this current to this current, is IS2 divided by IS1, and it is a constant M. IS2 and IS1 depends upon the dimension of Q1 and Q2 respectively. So if both the transistors are of same dimension, which means M is equal to 1, then same collector current will flow through both the transistors. But if the dimension of transistor is different, then IC2 is equal to M times IC1. The output current flows here, and this output current is same as IC2. This point is connected to external circuit, and output current is same as the collector current of Q2. If beta is infinite, which means that I am going to ignore the base current, so no current is flowing through this branch over here, then I reference is same as IC1. No current is flowing over here, so all current flows through the collector of Q1. But if and the ratio IC2, this current to this current, IC2 to IC1 is I out over I reference. This is because I out is same as IC2 and I reference is same as IC1, and this is equal to M, the constant, which is the ratio of dimension of both the transistors. Now I am going to consider that beta is finite. This means that base current is flowing from here and base current is flowing from here as well. So output current is same as IC2, whereas reference current will change now. Reference current comprises of three currents. Number 1 is IC1, which is flowing over here. Number 2 is IB1, which is flowing over here, and number 3 is IB2, that is flowing over here. So the ratio of output current to reference current in this case, as we already derived in class, is this thing, M divided by 1 plus M plus 1 over beta, where M is the constant that determines the constant that depends upon the dimension of both the transistors. If M is 1, which means both the transistors are of same dimension, then this ratio is given by 1 over 1 plus 2 by beta. Now there are two problems with this basic design of BJT. The topic until now we have already discussed in class, so this is something new, that there are two problems with this design of the BJT current mirror. First problem is dependence of output current on beta. As we can see in this relation, I out or I reference depends upon the beta. So output current is dependent upon the beta. Even though reference current is constant, output current can change if beta changes. So as you can see in this example, if I reference is 1 milliampere and beta is 100, then output current is 0.98 milliampere. But if beta changes to 50 from 100, then output current changes from 0.98 to 0.96 milliampere. Beta is something very unstable. It can change with temperature and some other parameters as well. So we don't want to rely on beta. We want that output current does not depend on beta and it is as stable as possible, and it should be constant, because the main purpose of BJT current mirror is to provide constant current in the output. The second problem with current mirror is the low output resistance. So let's have a look what is output resistance. This is the point of external connection in BJT current mirror. So at this point the voltage is V out and the current flowing through here is I out. What we want is that even though voltage at this point changes, but this current should not change. Whatever the voltage at this point, this current should remain constant. So this ratio is given by, so the ratio of change in output voltage to change in output current is called output resistance. It can also be found by this relation, VA, which is early voltage over output current, or change in output voltage to change in output current. What we want is that even though there is huge change in delta V or huge change in output voltage, output current should not change. This means that this ratio gives a very big quantity R out. So what we want is that output resistance should be very high and this current should be as stable as possible. But in case of this design, the output resistance is not very high. The output resistance of this current mirror is same as the output resistance of Q2. This R naught is output resistance of Q2 as well as output resistance of this entire current mirror. So I'm going to address both the problems one by one. So in the first step we are going to address the issue of dependence of I naught on the beta. So to address this issue we modify the basic design of current mirror, and now this new design is called current mirror with base current compensation. In this design we have added a new transistor Q3 over here, and the purpose of this Q3 is to make I out less dependent on beta. So let's derive the relation between I out and let's find the ratio between I out and I reference, and let's see how I out is less dependent on beta in this case. So in this design, same collector current is flowing through both the transistor Q1 and Q2 because we are going to assume that all the transistors have same dimension. Current flowing through this branch and this branch is IB, which is equal to IC by beta and IC by beta. Current flowing from this branch will be 2IC by beta, and because this current is the emitter current of Q3, so if we divide it with beta plus 1 we can get the base current over here. So this current divided by beta plus 1 gives us the base current of Q3, which is 2IC by beta into beta plus 1. Now I reference will be IC plus 2IC by beta into beta plus 1 as given by this relation. And since I out is equal to IC, then we can replace IC with I out, and now I out over I reference using this relation, when we simplify I out over I reference is 1 over 1 plus 2 by beta square plus beta. And since beta square is much larger than beta, if we ignore the beta, then the relation between output current and reference current is 1 over 1 plus 2 by beta square. In simple current mirror this relation was 1 plus 2 by beta, but now it is 1 plus 2 by beta square. So now output current depends upon beta square rather than beta, so it is less dependent upon beta now. We can also confirm this by using this simple practice question. If I reference is 2 milliampere and beta changes from 50 to 200, what will be the change in output current in both the cases? Number 1 is the case for simple current mirror, and number 2 is the case for the modified current mirror. So you can solve it yourself and see that the output current will change less in this case, in the case of modified current mirror, and it is going to change more in the case of simple current mirror. So in this way we have made I out less dependent upon beta by adding an additional transistor Q3. In the next class we are going to see how we can change the output resistance and increase the output resistance of current mirror.